Hello everyone. In this segment, I will discuss about extraction method of different phytoconstituents. Phytoconstituents are the bioactive chemical compounds that occur naturally in plants, and they are very much responsible for their therapeutic effects. These includes different types of secondary metabolites like alkaloids, glycosides, tannins, flavonoids, saponins, and terpenoids, and many more. Extraction, the term, basically refers to the process of separating these phytochemicals or phytoconstituents from plant materials by using suitable solvents and techniques. The main objective or goal is to isolate these compounds in a concentrated form for research, formulation, or therapeutic purposes. This present slide talk about different types of extraction methods, and whenever we are talking about different kinds of extraction methods, we must say it can be classified in two broad spectrum, in two different categories. Number one is conventional or classical methods, and number two is which is considered as the modern or advanced methods. So I'll start with conventional extraction method. These are the traditional methods by using simple apparatus and heat, which includes the process like maceration. What is maceration? Maceration is a process where soaking of plant material in a solvent at room temperature for a definite time period, and after that you will get the extract accordingly. So as far as the procedure for the maceration is concerned, I can say starts with a process where powdered plant material is placed in a container. Then suitable solvents like alcohol, water, or any other of the solvent, it may be benzene, chloroform, whatever, depending on the nature of the drug you are going to be extracted. Uh, these solvents can be added. The addition of the solvent, it should be done in different ways. First of all, we can add the solvents in singular way, means we can use a particular solvent. In few cases we can also use multiple solvents. It depends on the procedure, it depends on the nature of the chemical compounds, it depends on the entire concept of the drug or the solvent and the compatibility of both as well, on the basis of which we can easily proceed for the extraction for further process. Then let it stand for 3 to 7 days with occasional stirring. It depends uh, on the process as I mentioned earlier. And last, you have to filter and collect the extracts. So as far as the uses of these extracts are concerned, for heat sensitive phytoconstituents, we can use such process. Examples like tinctures, herbal infusions that can be prepared by implementing such extraction process. Next, moving towards a process named as percolation. What is percolation? A continuous process where solvent passes through the powder drug and extracts solvents with different constituents by using specific solvents. So as far as the procedure is concerned for the percolation process, I would say plant powder is moistened and packed into a percolator. Then in the next step, solvent is added and allowed to percolate. And lastly, the extract is collected at the bottom. There are few advantages, but the most important advantage of this process is that more efficient than maceration process. And as far as the use is concerned for the percolation process, I can say preparation of liquid extract, it uh, becomes much more easier by using such process of extraction like percolation. Moving towards another process of extraction, that is decoction. In decoction, boiling the plant material in water for a specific time period. And how can we proceed for this process? Coarsely powdered plant is boiled in water, followed by the mixture is strained and used. So as far as the use for decoction process is concerned, it's very simple, like hard or woody plant parts like roots, bark. These can be very uh, in a wide spectrum. It can be extracted. Phytoconstituent or phytochemicals present in woody material or bark material or such kind of uh, hard wood kind of material, we can easily use decoction process, and it may be very much handful to get the extract as well. So as far as the disadvantage or limitations of this process is concerned, I would say it is not suitable for heat sensitive compounds at all, because uh, as I mentioned earlier in the definition of the decoction process, boiling the plant material in water for a specific time period. It means if boiling is there, heat is required in such cases. So you cannot use heat sensitive compounds by using the process like decoction. Next process for extraction is infusion, where similar to maceration but shorter in duration and often uses hot water. So as far as the infusion is concerned, in broad spectrum, infusion can be implemented in two different ways. One is cold infusion, another one is hot infusion. In cold infusion, you have to add the solvent along with the drug and keep it for a specific time period, probably from 24 hours to 48 hours, maybe extend up to 72 hours max to max. And in such case, with occasional stirring, of course. And in case of hot infusion, you have to follow the same process, but the solvent you are using, it must be in a hot condition, but no direct boiling will be there. uh, if I suggest you water as the solvent, then it will be much more easier to understand. um, just assume water as solvent. You have to take specific amount of water as per the procedure, then boil it. After boiling, just remove the water and keep it somewhere else, and add the specific amount of drug in it, and just give a lid over that, store it with occasional stirring for 24 hours, in few cases 36 hours, in few cases it may be 48 hours, maximum extend up to 72 hours. And then after a specific time period, uh, you have to filter it and just collect the extract. After removing the solvent, you will get the concentrated extract, similar for cold infusion and hot infusion individually. So it is very much common for herbal teas and traditional remedies. In case of herbal teas, like you know herbal tea prepared by using lemongrass, herbal tea is prepared by using tulsi leaf, tea leaves is itself there. So in such cases, we are using hot infusion method. In cold infusion methods are also available, where uh, we are just putting the herbal tea leaves or any of the content which can produce herbal tea uh, with a specific solvent, more specifically water is the solvent that we use to drink. uh, just soak it for a specific time period, and then just when the extract will come out, you have to filter it and drink it accordingly. Simple. Now we'll moving towards the method method for extraction in a modern way. So in such cases, these are more efficient and eco-friendly, often involving automation and advanced technology. It means here some technical aspects will be there, apparatus will be there, instruments will be there. By using all such apparatus and instruments, we can figure out the extraction process in a more convenient way, in a more scientific way, so that you can get the maximum number of extracts out of the compounds. It doesn't mean that the traditional processes or classical processes are of no use. It is required, of course, but modern extraction methods are having their own aspects, and whatever I discussed earlier, it's having their own aspects too. So it starts with the Soxhlet extraction. It's very common and popular extraction method, even in different courses of pharmacy, or where extraction is there of the natural compounds. In such courses, extraction process by using Soxhlet apparatus, it is mentioned. So it's a very useful term. Um, Continuous extraction using by Soxhlet apparatus. It's an apparatus made up of glass. Different portions are there. Uh, Condenser is there. Specific round bottom flask is there. Soxhlet apparatus is there as a whole. You have to fix up the unit and then go forward for the extraction process. That's we can do along with the Soxhlet apparatus wherever we are carrying our extraction process. So moving to the procedure for the same. Solvent is heated, evaporates, and condenses back into the chamber containing plant powder. So you have to take the plant material as the coarsely powder form, and it will be taken in a in a in a in a cloth like paper, through which solvent can easily penetrate. The process repeats until the extraction process is complete. Increases yield and reduces time and solvent uses. That these are the advantages. As far as the use is concerned, it is very much useful for thermolabile compounds. Means uh, these are very brittle in nature. For those compounds, we can use ultrasound assisted extraction methods. So now moving towards microwave assisted extraction method, in short it is known as MAE. The principle behind microwave assisted extraction method is microwaves heat the moisture inside the plant cells, which causes rupture and release of phytoconstituents. As for the as far as the advantages of the process is concerned, it's rapid, it's having high efficiency, it's lower the solvent requirement. Then moving towards the supercritical fluid extraction process, in short, which is known as SFE, that is supercritical fluid extraction method. In such process, uses supercritical carbon dioxide above critical temperature and pressure, of course, as a solvent. The advantages for the process are this process is non-toxic, it is very much selective and residue free. For volatile containing or alkaloid containing or lipid containing drugs, we can easily use, or very much handful for such kind of drugs to go with the extraction process. So next, moving towards PLE, that is pressurized liquid extraction or accelerated solvent extraction, or AEC process, where high pressure and temperature to extract constituents is quickly observed, and it is very much suitable for solid or semi-solid matrices. For such process, the mechanism is all about uses the enzymes like cellulose, um, pectinase to break cell walls. As far as the benefit is concerned, it's like enhances yield value and environmentally friendly, means eco-friendly. The factors affecting extraction, this is the point, these are the points which is very much important before going to the mainstream extraction process. It is applicable for modern extraction process or traditional extraction process, for both. The type of solvent we are using, that is very much important, where polarity affects solubility of constituents. That is why the solvent must be chosen on the basis of the polarity of the particular solvent. Temperature, excessive heat can degrade thermolabile compounds and some heat sensitive compounds too. Um, pH of the solvent, that can affect the stability and solubility of the phytoconstituent present in it. Particle size, smaller particles increases surface area. That may be one of the major factor as far as the penetration on a particular surface area by the solvent is concerned. The time of extraction process, where longer time may increase yield value, but also risk of degradation is there. So in case of agitation, it increases contact between solvent and plant material. So if we go for the choice of the different solvents, these particular table can be very much helpful for choosing the solvent, where on the basis of the polarity we can easily go for the choice of the compounds through which we can extract the phytoconstituents easily. For example, if I consider water as solvent and it is a polar solvent, we can use for the tannin containing drug, which is a polyphenols and glycosides. Mm. Then in case of ethanol, which is a semi-polar, we can go with the flavonoid containing drug, alkaloid containing drugs. In case of methanol, which is a polar component, we can go with the phenolic compounds too. In case of chloroform, which is known as non-polar component, we can go with the lipids and terpenoids. In case of hexane, similarly, which is known as non-polar solvent, effective for essential oils and waxes. Uh, in case of acetone, which is a semi-polar compound, uh, semi-polar solvent, we can go with a wide range of constituents as well from the plant resources. So in preliminary phytochemical screening, which is very much important in relation to the extraction. Why? Because after extracting the products, you have to screen the product phytochemically whether the extracted product is of uh, specific value or specific character or not. To judge the character, we have to go for the different types of chemical test. That's why once extraction is completed, the extracts are subjected to various chemical tests to identify the phytoconstituents like alkaloids, flavonoids, tannins, saponins, glycoside. In case of alkaloids, we can go with the Dragendorf's test, Meier's test, Wagner's test. So these are the tests we can go with such products. In case of flavonoid containing drugs, we can perform Synoda test. In case of tannin, we can perform ferrichloride test. In case of saponins, we can go with the foam test. In case of glycosides, we can go with the Killier-Kinane test. More specifically, different chemical tests are there. Killier-Kinane test is applicable for cardiac glycosides, whereas anthraquinone glycoside, for anthraquinone glycoside, these are the Brontecker test is present. Sapon for saponin glycoside foam test and hemolytic tests are also available. So if I want to conclude such presentation, I would say the extraction of phytoconstituents is a crucial step in pharmacognosy and herbal drug development nowadays. Where people are working with the herbal products, people are working with the natural products from different origin. A suitable method must be chosen based on the nature of the plant material, type of the phytoconstituents, and the desired application is very much needed, on the basis of which we can go with the further process. Modern techniques offer better efficiency and are of increasingly preferred in pharmaceutical industries, which is of greater value in today's world. Thank you very much.